I mean, I feel like this, you already have.
Start up this recording. Right?
You already.
Yeah.
Yeah, the first time I went to see anything like special, it's just.
Oh.
It pays though, you know?
I went to every in the site board for 2 years and I quit out.
Damn.
Yeah.
I switched my boards now in my rehab slash hospice area, you know?
I don't know how you do that. Like I'd have a box of tissue with me every day, just.
No joke, man. No joke. They used to tell me the craziest, well, not anymore, I used to look at the site board for weekends, as a medical assistance. They'd be like, oh, if you miss my vein, I'm gonna wait for your report and beat the shit out of you.
Wow.
So-
Wow.
I'm not even kidding.
Wow.
The things that I would say.
Around, I had this patient called this word, you hear it in before you can like see it. Almost all of this, he's always like smacking his lips.
That's interesting. It's interesting. Right. Huh? Oh no, they just talking. Yeah. So I was getting everybody a few minutes just to like come in, you know. So something I was sharing with everybody that I tried the new cafe that we have, you know. It was okay, you know. The hours of operation, however, very disappointing. I think they're like open 10 to like 3. But I was right. Yeah. They can't get food, you know? So what I was thinking is that, you know, with our class, I know our class overlaps, like we finish at 3:30. So if you guys want to get something and then come in, go ahead. You know, like I completely understand. Like the hours is crazy. Like that's not fair. You know? Yeah. Cause if I don't do that, you don't get nothing. Huh? Nah, I already got my stuff. Yeah. Yeah, like I'm blessed that I have a break before class, you know. Yeah. All right, so does anybody have any questions from yesterday? I didn't post any homework yet, didn't post anything yet. I'm still working out the logistics and everything. I did record yesterday's class and I have posted it to YouTube. I just didn't give y'all the link yet, but I will give it to y'all. All right. On Brightspace. So I'm just gonna like give you like the link for the class and you just click it, you can rewatch it and all of that. And then you can just do the homework from there. You know, I haven't posted the homework fully yet, you know. So what I like to do is I like to look at the homework first and make sure that it's good, you know, kind of thing. It's too much. So really what I'm doing is I'm chopping off questions and then I give y'all like a little yeah.
Yeah.
Yeah. Yeah. I try. All right, so let's pick up where we left off. All right. Let me see if this works today. Try. Did it work? Damn, it didn't work.
It's gonna rain tonight or tomorrow. Remember I said that.
Dang.
It's not Friday, believe me. Right, I feel it.
Oh, she got that superpower. She got that superpower.
That's your lifelong injury.
Oh man.
You did the leg or the back to lead, tell me how bad. It's not that, it's four. Yeah. Oh, you know.
Y'all got that superpower. That's what. Right? Oh man.
Yeah, you did on and on. Yeah, I have a daughter and well, yeah, they both mine.
They give you the same. That should bump you up.
Yeah. And you know what's crazy? I'm already giving.
I had that, I do it. Giving up with blame, but it.
Y'all strong. I don't even know. Shoot. Last semester, like a piece of paper slipped my finger and I got cut. I was crying. I can't. I can't. All right, let's look at this real quick. We're doing operations with fractions. We're gonna be adding and subtracting fractions. Cool, right? All right, so unlike multiplication and division, addition and subtraction does not follow a rule that sounds like do the operation to the top and bottom separately. Instead, they follow a rule of a different pattern, one in which where we will see many times ahead. So adding and subtracting fractions requires that the fractions be of the same kind. So for example, we will have a way to understand adding six to sixth, but adding a six to a fifth will require that we express them as fractions of the same kind. Blah, 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 right? Remember yesterday when we were trying to find the LCD to make the fractions equivalent? They have to be equivalent in order for them to be added or subtracted. That's what that means, right? I forgot this thing don't work.
So you gotta change them to be equivalent if they're not, right?
Right. So let me give y'all the sauce real quick.
And that's only for adding and subtracting.
Yes. For multiplying and dividing, you just go straight across. That's easier, right? So adding and subtracting fractions. So to add or subtract two fractions, write the two fractions using equivalent fractions if necessary with a common denominator, right? And then you want to add or subtract the numerators while keeping the same common denominator. After that, if possible, reduce it, right? If possible.
Want us to come up with a,
What?
with the fraction.
No, I give you them.
Okay.
Yeah. Wouldn't that be something? I'd be like, yo, just make your own test, right?
Okay.
That would save me so much time. Like, listen, like go write your own test, right? I'm gonna look it over. If I approve it, just do it, get 100, then that's it. That's why I gotta approve it. Nah, if I was making it, I'd make it super easy. Like, All right, so how about this? Let's say we want to do 3/4 plus. Let me get an idea. What's a nice number? Uh, let's say 3/8. I'm just making it up, right? So what I want to do is I want to make these fractions equivalent before I add them, right? Long story short, I want them to have the same denominator, right? So what would the LCD be here between 4 and 8? What do we think? Go ahead. Not 4, 8, right? LTD means lowest common denominator. Yeah. So 8, right? So what I'm looking for is I'm looking for the largest number that both of them can go into, so to speak. Yeah. Yeah. Right. Because I can change the 4 into an 8, and I can keep the 8 as an 8, essentially, right? So what can I multiply 4 by to make it into an 8? By 2. But I have to be fair. What I do to the bottom and to the top, right? And then what can I multiply 8 by to keep it as an 8? 1, right? But I got to be fair. What I do to the bottom, what I do to the top, right? So now what do I have? This becomes what? 6/8 plus 3/8 now. Now that I have the same denominator, you add the numerator, all right? So what's 6 plus 3? All right, so 9/8. And that's it. That's how you do it. Yeah. But just to be clear, this is what happens. 6/3. 6 plus 3/8, like that. That's how you get the 9/8, all right?
That's how you have to write?
Or
you said either
you
or.
can just give me the answer. Questions on this though?
The denominator, the bottom, and the top.
Numerator.
When you
Yeah.
have like a whole number doing that, you just add the imaginary one.
Right, put it over 1 and then same process. Yeah. 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 I'm sorry? That's cool. I like improper fractions. I was showing you the whole mixed number thing in case you come across a question that's like, all right, put this on a number line, right? Because from a mixed number, it's easier to put on a number line than from an improper fraction, you know? I mean, looking at this, could you guess which two numbers this fraction is in between?
1, 2. And where?
Perfect. 1 and 2.
My number?
Yeah.
I'm not.
This is why I'm saying you flip it into a mixed number so you could clearly see like, all right, this is gonna be 1 and 1/8, right? So you know that's gonna be in between 1 and 2. Oh, yeah. All right. Let's try something easier. Here's another example. Let's say, how about 2 minus, what's a good number? Let's say 4/7. How about that? 2 minus 4/7. Tell me what to do. Good. So 2/1 minus 4/7. What do I do after that? What is the LCD? 7. Good. All right. So LCD is 7.
Then we're gonna do 2 times 7 and 1 times 7.
Well, 1 times 7, right? And then what you do the bottom, you do to the top,
Oh, right, sorry.
right? And then 7 times 1, which you the bottom, you do to top, right? And then let me scroll down a little bit. So 2 times 7, 14 over 7 minus 4/7, right? So what's my answer? 10/7. Very good. Questions on this? Good. All right. Yeah, good. It's all right. You don't approve? It's too simple?
Wait.
I got you.
Right,
It-
that's what.
It's improper, but I would accept that as an answer.
And
Yeah.
what if the stuff says keep going to make it simplest form? You can break that down?
Yeah, like if I could have reduced it more, then reduce it. Yeah.
You would have done that trick before you got the 10/7.
Yeah.
You showed it there.
Yeah. Cause I be struggling. Y'all don't see me, but I'm over here counting my fingers and everything. I'm like,
Make my little mistakes on the page.
y'all can use calculators though, so it's all good.
Oh,
Yeah. Yeah. I got you. TI 36X Pro. Yeah. Yeah, I'm gonna give y'all a link and all of that when I finish all the stuff I'm doing. Try this out. I'm over here struggling. I'm trying to figure this one out myself. Man.
Wait, 5/6 equal 1/8.
You gotta find out LCD is not 8.
No, it's a-
I got it. Yeah. For real, I was counting my fingers though the whole time. Yeah. I'm sorry? You finished? All right, let's go over it. All right. So what you found as the LCD? Okay, good.
Multiply the 8 by 4, change at the top, then
Good.
6 by 4, and alpha is in the 5.
You multiplied the 8 by 4?
No.
Hmm.
I think it's in 4.
So the 6 is by 4, right?
Not 4, then
Which uses bottom, you to the top, and 8 by 3, good. What you do to the bottom, you do to the hello, all right? And then we just multiply and then that's it. So 5 times 4 is 20, okay?
144.
Minus, what's that, 3 all over 24. So what is this?
120 over 144.
120, you
I
said?
mean, I'm sorry, 100 times.
Okay. Right.
Yeah.
Okay.
Yeah,
That's it. So we good?
How do you do that? Okay, real quick,
Which one?
yeah,
Mhm.
let me ask you a question. You see
Yeah.
how you got the LCD 24,
Gotcha.
right? Boom. Why you not 6 times in 24?
6 times 4 is 24, right?
Yeah,
And then what you do at the bottom, you do to the top. And then
I always got hate.
I got you. I got you. Like I said, you will have a calculator, so don't worry. But this is something important for you guys to know, going into nursing and all of that.
Say that again. Somebody said I gotta go and tell me. I was trying to figure out how, like, how do.
Oh, how to get the 24? All right. All right, so look, you know that 6, right? You know that 6 is what? What two numbers multiply give you 6? 2 and 3, right? And then how about 8? What numbers multiply give you 8? 2 and 4, right? So 4 we know is what? 2 times 2, and then there's just one more 2, right? All right, so all you have to do, take one of them for the LCD, right? Take one of them. It doesn't matter which one. Let's say we take the first one, right? Which is 2 times 3, all right? And then now you add in what's missing, right? I already have 1 2. I just need 2 more 2s to complete it. And then that's your LCD right there. 2 times 3 times 2 times 2, which is 24. Yeah.
Yeah.
Oh, no.
That's what
Yeah.
I told like the one.
So the whole reason for finding the LCD is so that you could get the two denominators to be the same. Then you could do subtraction or addition.
I
Yeah.
gotta do for that stuff.
Yeah.
Yeah, so remember guys, right, after we figured out that 6 times 4 is 24, and 8 times 3 is 24, and then we got that common denominator, then we have to also do 5 times 4, which is 20. So now we have 20 over 24, and we have to do the same way we did 8 times 3 for 24. Now we gotta do 1 times 3, which is 3. So then you end up with 20 over 24 and take away 3 over 24. And then when you subtract it, you get 17 over 24. I get stuck out here on the denominator as well. Yeah, I get stuck too.
Gotcha. All right, we got some more vocabulary stuff before we get to our next example. So just bear with me a little bit. Just a little bit. Just a little bit.
Wait, hold on.
My fault. Go ahead. Remember, I am recording this, so like if y'all missed anything, y'all could always get it back. You know?
This is super helpful.
Okay, you good,
Not
thank
bad.
you.
Thanks. All right, bear with me 1 second. All right.
What's the sign?
Me? I'm Sagittarius. Yeah. All right. It does. All right, so when a child learns to count, numbers only go in one direction. They get bigger. In fact, for thousands of years, civilizations rose and fell using only positive numbers. After all, numbers first arise in answer to the question, how many? How many what? How many things? The things that bring things which might be picked off, looked up, or put on a bookshelf, etc. Negative numbers are more complicated. It doesn't make very much sense to say I have -5 books, for example, right? Historically, negative numbers arose to take into account losses or debts, right? And was undoubtedly connected to the emergence of money or coin, right? In this way, there is a meaning to the sentence, I have -$5. It simply means I owe $5. So instead of having $5 in the context, to owe is the opposite of to have, right? And negative numbers will be the opposite of the more familiar positive numbers in a way that we made precisely clear. So for now, let's say that every positive number has an opposite, And this opposite of a positive number will be a negative number, right? 0 is special. It counts. It just counts differently. You hate negative numbers? I hate negative numbers too, especially my bank account. Every time that thing says negative, I'm like, what you mean? Like, for me, it's like I know I bought it, but I didn't think he was gonna actually take it out. Like I thought it was just like I ain't know that the bus actually really was charging me. I thought it was just let's swipe my card and then I go, you know. So 0 is special in that neither positive nor negative, right? It is neutral, right? And we say that 0 is its own opposite. Our goal, right, will be to describe how to perform the basic arithmetic operations, adding, subtracting, multiplying, dividing with these negative numbers. Right. So as soon as we allow negative numbers, we need to take into account two aspects of every non-zero number, its sign, which can be either positive or negative, and its magnitude. Right, which is a positive numerical value. A positive number is indicated by a plus symbol, right? Along with its magnitude. So for example, +5 will represent a number whose sign is positive and whose magnitude is 5. A negative number is indicated by the minus sign, right? Or negative symbol, right? Along with the magnitude. So for example, the symbol -5 will represent a number whose sign is negative and whose magnitude is 5. Notice that the magnitude of a non-zero number is always positive. Operations with sign numbers will have to take both of these aspects into account. So the magnitude of a number is represented symbolically by means of the absolute value. All right. So that's those two bars that they have right there, right? So for example, we can summarize the preceding paragraph with the absolute value of 5 is equal to 5, and the absolute value of -5 is equal to 5. All right. So long story short, what is absolute value, right? It's a measure of how far a number is from 0. This is why it's always positive, right?
Negative, right?
Right.
A negative.
It could be negative or positive, right? Once you take the absolute value of it, it's going to return to you a positive value, right? And the reason why it's positive because it's measuring how far away it is from 0.
Oh, so it goes back.
Right. It could be back, forward, etc. Right? Yeah. Right. Mhm. So we've already seen that 0 is a special number when it comes to signs. In fact, the very idea of opposite that we have used to motivate the negative numbers will be defined relative to the number 0, along with the fact that the number 0 will be neither positive nor negative, right? We will say that 0 has a magnitude of 0. Warning, do not confuse the meaning of symbols for the sign of a number with the meaning of symbols for addition and subtraction. Right? It's an unfortunate fact of history that the symbols are in fact the same, but the meanings are very different, as you will see. All right. So let's take a look at that. Yes, you should.
Yeah.
You should.
You know, it's not hard, it's just a lot of memorization. Like formulas, you do that.
Honestly, I don't expect you to memorize nothing. I'm giving you a formula sheet.
You do, because like when you put those fractions, what's the first step? You gotta remember.
Type it in your calculator, click enter. That's your first step.
That's
All right. Oh, whoops, hold on. Whoops.
Like it's some kind of like never-ending puzzle with math. Everything is connected in some kind of way, and instead of making it easier, it makes it harder for me.
What's your worst subject?
My worst subject?
Yeah, 'cause it's not math.
I took music and I failed it. Yeah, that joint was hard. Yeah. I had to listen to like really, really old tracks, and I had to identify like who wrote the track by listening to it and stuff like that. And then you had to learn how to like write music and all that. Like it was hard. I don't know. See, you got the edge. Like for me, I didn't know nothing. It's a lot. You smart. You smart. Nah, I took art. Art was fire over here. Yeah.
Yeah, I just.
That's what I said. I took it writing intensive and everything. It was good. Yeah. English was hard too, though. I'm not going front, but not like music. Music was a special hard. Yeah. All right, convention. So when a sign is not indicated for a number, it will be assumed to be positive. So for example, 5 means +5. All right. So let's talk about the graphical representation and comparison of signed numbers. While there are several ways to understand negative numbers, the graphical representation of numbers on a number line, bless you, is particularly helpful. So recall that a number line has 3 essential components. It extends infinitely from the left to the right. It has a special point representing 0, right? It has a specific unit length, right? Its representation, hold on a second. Yeah. Um, sorry about that. In this representation, positive numbers will be those numbers represented by points to the right of 0, while negative numbers will be those will be represented by points to the left of 0. So when we represent a signed number on a number line, the number's sign will tell us which side of 0 to be represented. So while its magnitude will tell us the distance in terms of its specified unit length, right, from the representative. So yeah, just basically talking about the components, right, of the number line, right, which is important to know too. All right. From the representative, point to point, representing 0. So thinking of the magnitude as the distance from 0, right, corresponding to the convention that magnitudes of non-zero numbers like distances are always positive quantities, the number line representation of signed numbers also gives us an easy way to visually compare, right, comparisons of signed numbers. By comparison, we mean either less than, equal to, or greater than, right? Symbolically, these 3 possible comparisons are written as this is less than, right? That's the way it looks. Equal to, the 2 bars, this parallel, right? And greater than is the opposite of less than. Flip around, right? So, yeah.
Like the bigger number.
Right. That same thing, that same idea. That's exactly what it is. So comparing positive numbers, right, corresponds to our standard notion for quantity. So for example, 15 is less than 27, right? So I know that this is on your homework. You're gonna get 2 numbers and which one's bigger?
That's the little.
Yeah, that's it, right? So comparing positive numbers in decimals or fraction notation is only a little bit more challenging. So that we first need to see them as quantities before comparing. So 0.043 is bigger than 0.0099, right? So 4 pennies is less than a penny, essentially, right? No, 4 pennies is greater than a penny. Whoops, I misspoke. So since, okay. Yeah, right.
The further, the higher the number.
The further out the number is, the smaller it is, you know? Yeah. Well, you don't.
No, but I mean.
Because you buy things in the supermarket, right? So they were charging you 4 pennies versus a penny, you know which one is more. It's the same idea, you know? All right, so since 0.043 is equal to 0.0430 and 430 is greater than 99, right? So here's how they got the 430 greater than 99. They moved the decimal point over 4 times. But what you do to one, you have to do to the other. So when you do it to the other, right, it becomes 99. And the first one becomes 430. So you could clearly see 430 is more than 99. Yeah. So that's another way to do it too.
At 0.
Right. Now let's say you had a fraction. 3/11 is less than 2/7. But we know how to do that, right? LCD. Make them equivalent, then you can see which one is bigger, right? The one with the bigger numerator is bigger. And that's it. Right? So since 3/11 is equal to 21/7 and 2/7 is equal to 22/7, we know that 21 is less than 22. So there you go. All right. Which is bigger between -10 and -15? Very
Move
good.
it to the middle.
Very good. Yep.
That's the.
Very good. I'm impressed. I'm impressed. All right. So you good for the first test, right? All right. So using a number line representation and comparison of positive numbers as our guide, we will translate less than as to the left of and greater than as to the right of. In this way, -10 is greater than -15. Since the point representing -10 is to the right of the point representing -15 on the number line. This reasoning can be surmised in the following guide for comparing sign numbers. Note that the signs and the magnitudes are both important in comparing two sign numbers, all right? So the lesser of two positive numbers is the positive number with the lesser magnitude, and the lesser of one positive and one negative number is the negative number, all right? The lesser of two negative numbers is the negative number with the greater magnitude, the most negative number. All right. I'm gonna clarify that in a little bit, don't worry. I'm gonna clarify that in a little bit. All right. It'll make more sense when we start doing the problems. So now let's talk about operations. All right. With sign numbers, addition and subtraction. How much money do you have at the end of the following situations? Think of debt as being represented by a negative number and money as you have as a positive number. So when you have money, that's positive. When you bought something, that's negative, right? So for example, you have $100. Your partner hands you $250. How much you have now? 350, right? So you just add them two together, right? You have $100, your partner hands you an $80 phone bill. How much you have now? All right, that's it, right? You just subtract them two. All right, you have an $80 phone bill, your partner hands you $250. How much you have now?
No. Yeah.
What is it?
170.
170, right? All right. All right, so we good. All right. You have an $80 phone bill, your partner hands you a $100 electric bill. How much you have now? What is it?
Hold on.
No, I didn't.
Negative one?
I did.
-180. That's it. All right, all right. So in all four scenarios, you have something and your partner adds to what you have, but the way you treat the four cases is different. All right. So that's what I'm alluding to right here.
Can you just repeat the answer and fine, please?
So the answer is -180. All right. Because you have to pay both of those bills.
On your left.
And I didn't tell you that you had any money to pay it.
So like, what was that?
Yo, we all lost in that scenario. Yo, that's why we here trying to get our degrees, you know? Yo, we all on the same page. Oh man. All right, we're gonna bring this up. Hold on. Don't worry, I'm gonna get back to more examples in a little bit. We're just building it up. But like I said, I like to tell y'all how to do it before I show y'all how to do it, you know? All right, so the goal of this section, right, is to arrive at rules for adding and subtracting signed numbers. So because we now have to keep track of two aspects of each number, its sign and its magnitude, the rules will be more complicated than the rules for adding and subtracting positive numbers that we learned in grade school, right? So adding sign numbers. Before listing the rules for addition, right, let's give another illustration using the graphical representation of numbers on a number line. If you had to draw a picture using the number line model, right, down here, right? Yeah. of the following equation, 2 plus 3 is equal to 5, right? Perhaps the best way to do it would be as follows, right? First, draw an arrow starting at 0, right? Stretching all the way over to 2, right? In the positive direction to the right. Then draw another arrow, starting where the first arrow ended at the point representing 2, and then stretching it 3 units to the right, right? Also in the positive direction, the sum is represented by the point where the second arrow ends. So at the point representing 5. In other words, to do 2 plus 3 is equal to 5, right? You go over how I would do it. I would go over to where the 2 is, and you want me to add 3 to that, right? So I'm moving 3 spaces, 3 units, excuse me, to the right, which is at 5. That's how you do it on a number line addition, essentially, right? Any questions on it? Are we good? Yeah, remember this from like, if you want to. It's being recorded, so you could write it down at home afterwards.
Oh,
Yeah,
you said from high school, right?
yeah. Mhm. You didn't learn this in high school?
Yeah.
Okay, okay. I got you.
I
Coming
think
back.
the tallies were much easier.
Then Filipino, so you may know.
Oh, I hate tallies. That's coming.
This number line.
I hate tallies, but that's coming. Nothing I hate more than tally. Mm-mm. All right. All right, so we already know 2 plus 3 is 5, right? The advantage of this graphical representation of adding is that it is very easily adapted to take into account negative numbers. So we will simply draw negative numbers using arrows pointing in the negative direction. Arrows pointing to the left, for example, in the figure, line representation of the sum of 4 plus negative 5. The result indicates that 4 plus negative 5 is equal to negative 1. So, all right. So if you take a few minutes to draw a few more of these number line pictures, a few things should become clear. First, the pattern depends on whether the two numbers are being added have the same sign or different signs. So depending on that, we will end up with whether you're adding or subtracting the magnitudes. All right. So 4 plus negative 5 is equal to negative 1. So basically, if I had a number line here, you'd be at 4. You're taking away 5 units, so you're going to the left.
Yeah.
So that's why you end up at negative 1, right? Alternatively, another way to do this, you see different signs, you subtract, keep the sign of the larger number,
Yes, that's the one.
all right? That's another way to do it, all right? Let me give y'all a little graph so y'all can see it. I don't want to draw it because my handwriting is not so pretty. So this is what I'm saying. Start at 4, you go 5 units to the left, you end up at negative 1. All right? So that's adding negative 5 to 4. All right, let me give y'all the sauce and then we could actually try some examples. All right. So here go the rules for adding sign numbers. So to add sign numbers with the same sign, so when they have the same sign, right? The sum has the same sign as the sign of the two original numbers. The sum has a magnitude, which is a sum of the magnitudes of the two original numbers, right? So to add sign numbers with different signs, right? The sum has the sign of the number with the larger magnitude of the two original numbers. The sum has magnitude, which is the difference of the magnitudes of the two original numbers, subtracting the smaller magnitude from the larger magnitude. Blah, blah, blah. You see the same signs, you add and you keep the sign. You see different signs, you subtract the number, right? And then you take the sign of the larger number. That's it.
That means you see
Right.
two signs the same.
Right. You just add,
Yeah.
but keep the sign. Right. And if they have different signs, you subtract the two numbers, but keep the sign of the larger number. That's it. Right? So that's the trick. Anyway, let's have fun. I got you. I got you. Do this for me. -12 plus -15. What's that? What's -12 plus -15?
You said it's the same size, sorry, it is the same sign at the numbers? Oh.
So what's the answer? Good. That's the answer. Very well. Questions on that? Anybody? All right. That sounds good. That sounds good. That's true. Mm-hmm.
So I got that if the two signs are the same,
Mm-hmm.
signs remain the same.
Mm-hmm. Huh?
Yeah.
I am. I am.
And you said if the signs are different, you subtract and you keep the sign to the bigger number.
Right.
That's what you said.
Mm-hmm. So how about this? Say I have -4 plus 12. What would the answer for that be? Very good. So I just want to make a comment here, right? You notice how for the -4, I put it in parentheses, right? Because I want to differentiate between the negative and positive sign and the addition and the subtraction, right? So that's why you see me write it in parentheses. Mhm.
Yeah, you just said.
You want to the right? Down here.
Right.
Makes sense.
All right. How about -4/5 plus 3/10? But y'all know what to do already. I did. What do you think we should do first?
Find the common denominator.
Good. What is it?
10.
Good.
Yeah.
All right. So how do I change a 5 into 10? Good. And what you do to the bottom, you do to the top. And how do I keep a 10 as 10?
1.
Times 1. What I do to the bottom, do to the top. All right. What is that? -8. Good. Over. Good. Good. Plus 3/10. Good. What's the answer?
Yeah, -5.
Okay.
Yeah.
Reduce it for me. What is the answer? Good. I'm happy. Mhm.
What if you don't reduce it?
I'm chill.
Yeah. that's fine.
Your next class might not be. Sometimes they want it reduced. I like fractions. Or if you get like a question that flat out just told you to do it, then
Right.
yeah. Y'all want some more? All right, more's coming. Don't worry, more's coming. More's coming. I mean, that's what the homework is for, right? Practice.
But when I get home and I try to do homework, it may not go this smoothly.
That's okay. Just keep going. So 5 goes into 5 once, 5 goes into 10 twice. Yeah. Also for your homework, right? Like y'all have unlimited attempts. I don't care how you get the homework done, just get 100. Like straight up.
And a question different me.
And I promise you, I'm not looking at how many times you try. Like, yes, the homework does tell me how many times you try. I really could care less, right? Just get 100. That's all I care about, you know? Mhm. So what should be clear from the above rules and examples is that addition of signed numbers is a two-step process corresponding to the two parts of signed numbers. So we first establish the sign of the result. We then determine the magnitude of the result by either adding or subtracting the magnitudes, depending on the signs of the original two numbers. Warning. Notice that these two rules do not say that a negative and a negative gives a positive, which is a famous distortion of a correct rule, right? As you'll see below. So in fact, the sum of negative numbers is negative, not positive, right? So when you add two negative numbers, you're going to get out a negative answer, not a positive answer, all right?
Right.
But some people say a negative and a negative is positive. That's not true. All right. Flip side. All right, so let's talk about 1 second. Right here, right here. We're going to talk about subtracting sign numbers. All right. So we will not make a new list of rules for subtracting sign numbers. Instead, we will illustrate a procedure to rewrite subtraction problems as addition problems. All right. Long story short, I don't know if y'all ever heard this, right? But there's actually no such thing as subtraction. That's made up, right? What it is that it's actually addition, right? So you're just adding negative numbers. That's the truth, all right? So this whole time we thought that there was subtraction, like, nah, you're just adding a negative number to a positive number. And that's how you get the smaller number out. Theoretically speaking. But you did it before though, right? When you had the bill and you had the money in your hand, you knew that you had less. It's the same idea.
It's
Mhm.
like the same concept.
Right. Theoretically speaking. All right. So when subtraction, right, was first represented in grade school, is usually described as an operation of taking away. Unfortunately, while this analogy still holds for negative numbers, it can be more confusing, right? Is it obvious to you that taking away debt has the same effect as giving you cash? All right. So instead, we revert to the number line representation that gives us a clue to our rules for adding sign numbers above. So what would the number line picture look like for the subtraction problem 6 minus 2 equals 4? All right, so what do you guys think that would look like?
Whatever, right?
Mhm. And you go back 2 numbers, right? That's it. So we start at 6 and we're going to jump back 2 units, boom, to 4.
Yeah.
That's it. All right, sure, go ahead.
Why can't we just leave it like this? What it is?
Yeah. Nah, statistics is even easier than this. Yeah, this is the hard part. Yeah.
It's not very.
It's pretty.
No, it's not that hard.
You know. You like the first.
You're gonna see like when we get to the statistics part, that's the easy part. Like this is the hard part of the class. So I figure let's do the hard part first, and we get to the easy part. Huh? Stats, yeah. Yeah. So in statistics, we're gonna be adding numbers, subtracting numbers, and all that. So you got to know how to do that first, right?
Well, so then it would be a higher, let's say, like a high school, you sat for that.
Where you?
Would it be like similar to that?
Similar, yeah. Very similar.
That increase.
So you have an edge. And it was easy, right? See? I told y'all it's easy. So she took it already. Yeah. All right, so look, subtracting positive 2, right, is represented with an arrow going in the opposite direction, taken away from the positive direction, as you can see in the figure above. Now, compare what we saw there to the number line representation of the addition of 6 plus negative 2. The two pictures will be identical. So we have labeled them slightly different to take into account that the second diagram depicts addition, where the first diagram depicts subtraction. These two number line diagrams reflect a very important mathematical fact. That is,
This is a little confusing.
It is? Don't worry, just take it in.
Oh, good.
Oh, so you, when you're trying, well, look at my number line, but so you're trying to say, I go back to 6 and then just go back to the spaces again,
Mhm.
but. So it would be +4 because 6 is the bigger number and 6 is a positive.
And we're taking away 2 from 6 to get
Right.
4, right?
Okay.
That's it, yeah. When y'all go home, y'all could explain this to y'all kids. You know?
Yes.
And they- Really?
Little ones, the girls, boys.
My class,
The
like-
referee, I'm tired of being a referee.
See that?
Yeah, my daughter.
And what's their trick? Do they count their fingers?
I don't know what she does.
I mean, my oldest son, he's really smart.
That's
And I
amazing.
wish I had that gift.
You do. You
Yeah,
do.
somewhere, I mean, music, reading.
Yeah, you do. You do. All right, so here's a secret, right? Subtraction is the same as adding the opposite, right? As I was saying before. To be precise, right? We need to understand what the opposite means. In the context of addition, the opposite of a number is a number with the same magnitude but opposite signs. So the opposite of 3 is -3, right? Whereas the opposite of -8 is +8. Right? To be more precise, we say that two numbers are opposites if their sum is 0. Right? So notice that 3 plus -3 is 0, right? And -8 plus 8 is 0, right? So many times it will be convenient to think of a negative sign as representing the opposite of. So the symbol -5 can be thought of interchangeably as -5, right? Sorry. All right, and the opposite of +5, right? More importantly, the symbol a negative of -12 should be understood as the opposite of -12, which of course is +12, right? So we are now going to outline a procedure for subtracting sign numbers. Keep in mind that in any subtraction problem, the order of the number matters. So for example, 7 minus 5 is not the same thing as 5 minus 7, right? In mathematical terms, subtraction is not commutative. So remember with addition, I could flip the numbers around and add them and I get the same answer. Now with subtraction, all right?
Oh,
Yeah.
he's one of my teacher.
Oh, for real? For real?
High school, I was like, so.
Seriously,
That's great.
yeah.
Oh, for real. Sound like she had a deep voice.
Filipino one day, good luck.
Do they? I feel like they like nursing.
A lot of them, yeah, I used to work at
Nah, but they nice people though.
Yeah, yeah, very.
All right, so procedure for subtracting sign numbers. Rewrite the subtraction problem as the sum of the first number and the opposite of the second number. And then apply the rules of adding sign numbers, and then that's the answer. Simple, right? So in applying this procedure for subtracting sign numbers, it is important to emphasize the difference in meaning between the symbols. So for subtraction and the symbol for negative, right, or opposite of, most times reading the problem out loud will indicate whether the sign, the minus symbol, whatever, represents a minus or represents a negative. All right?
You know something, when you give the examples, I can somewhat understand, and then when you read this, it's like you're speaking a different language. You know,
Really?
I don't understand nothing that you're reading.
Really?
It's just confusing me further.
Okay.
Those are quite traditional.
All right. So tell me what to do here. -10 minus -12. Tell me what to do. Just do exactly what I said to do above. Yeah. You got it? Yeah. All right. Tell me how to do it.
Oh, they both on.
Mhm.
Well, I mean, the higher number is the down. But the higher number is the negative, you can keep because the negative 12 minus negative 10.
Mhm.
Well, the positive.
True, true. So a little, he did add it, but he just said it in a different way.
So I,
No, no. So look, when you're dealing with subtraction, right?
But you gotta keep the, minus, well, the,
can you repeat what you said again?
yeah.
Yeah.
You gotta keep the negative sign in front of the 10.
Mm-hmm.
Right, that doesn't go nowhere, but you're still adding the 10 and the 12. Yes.
All right. What does negative of negative 12 mean? I want the opposite of negative 12, which is. So what's negative 10 plus 12?
Oh, that's what you're saying.
Hmm.
No, but you're right, because you can't do one and.
But low key, I did say that earlier in the words.
But didn't you say, see, I usually get that, but I didn't say nothing because you said that the two negatives have to be negative after.
Right, that's what I'm saying.
When you're adding, but this is subtraction, right? So with subtraction, right? You're gonna do the opposite of the second term, and then you're back to the adding scenario.
So you changed the bigger number to a positive.
You change the second term
Second.
to the opposite, and then you add it. Got you. One more.
I got that. And why we-
Alright. Yeah. How about 15?
Listen, They make it and they all whip up their phones, everybody, not
They on their phone?
everybody.
They on ChatGPT?
No, not-
They be like, my patient doesn't feel good. I gotcha. Positive 15. Yeah. Anytime you don't see a sign, just assume it's positive. Alright.
That's slow. Is it possible? Yeah.
I didn't even do it
Bring
yet.
it.
So you're gonna keep the 15, right? And then you want to do the opposite of negative 3, which is so plus 3, which is what's he? That's it.
Why added it?
Yeah.
Why not add it? Wait, I did.
Why?
It's basically telling you like 13 minus minus 3, like go that way.
15 minus.
But you added for the party.
Right? So that minus means I want the opposite of it. Hmm. Right. That's all it is. I got you. I mean, I'm gonna give y'all a few more for homework. I got y'all.
Gonna put it on birthday, right?
Actually, no, that's gonna be on YouTube. Yeah.
If I do the number line, I'm always gonna get it right, but realistically, I'm not gonna wanna draw a number line for really large numbers.
That's true.
But
Yeah,
I
that's fine,
get it
go like
right,
this,
I
that's what I
do the
do.
number.
Don't worry, you'll always have a calculator, so we'll be good. Alright.
That's all you got it.
Yeah, so you'll be
You
good.
just train without these things. How do you?
Pretty much, you know.
This is another, okay.
Yeah. This so y'all can have a conversation with y'all kids when y'all get home. Like, nah, it's done like this.
I think my son will help me.
So do we add?
Always. Because remember, there's no such thing as subtraction, only addition.
Right. And nobody.
So we're trying. Was it positive 23? What you got?
It's
Mm.
You got negative 12? Alright. We did.
I didn't even do it yet. I'm not even sure. It probably is. I'm trying to count my fingers right now.
I got this. Right, that's.
Yeah, that's it.
Yeah.
Yeah, yeah.
Can we maybe?
But that's the hard part though. What's that? Yeah. I'm trying. I'm trying to get the answer from you because I don't even know. I'm trying to check myself. Like,
That's not, okay.
I was about to ask, so I was supposed to ask. I was trying to get my places wrong.
right? Yeah.
Thank you. And then I'm keeping the negative, correct?
Yeah.
What y'all got? I heard negative what? 12. Okay. All right.
I'm confident.
I know you are. That's right.
Y'all probably got it. I don't even know. All right, so look, first thing I'm gonna do, I'm gonna keep the negative 15. And then I want the opposite of -8, which is okay. So what's negative 15 plus 8?
23.
It is?
I mean, I don't know, just 15 plus 8.
I put negative 23.
It is?
No. I put it
I put it on.
Negative seven is
Because I'm saying your bill was $15 and you had $8 to pay it. So how much you owe? Alright. We see that's the hard part over here because that's why I'm over here like yeah.
Help myself.
Because you know what I was doing? I took 15, right? And then I took 5 from it, right? And I know 8 minus 5 is 3. So I'm like, damn, what's 10 minus 3? Like, yeah.
Yeah.
So just because the bill is $15 and you have $8 to pay the bill. That's what yo, I'm right there too. I was right there thinking like, no, but it can't be.
You do it like that, like, you see this, the number, add 8 to the figure, like 8, 9, 10, 11, 12.
That is what I'm doing. I'm adding 8 to 15. That's like,
Okay, okay. That's like a little trick we can always do that.
Yeah.
And keep the sign of the bigger number.
Right.
Yeah.
That's exactly what it is. I gotcha.
Now we read the broken line, makes it correct.
That one was type hard though. So let's take it down a beat. Let's take it down a beat. All right. Let me
Well, make it hard though, so we can get it.
All right. How about 1/4 minus 5/6? But that's easier though, right?
Yeah, that's what we.
So there's no negatives, it's just 2 positive fractions.
But don't you have to change that thing?
You gotta get the same denominator.
Yes.
Mhm.
What is the common denominator?
I don't even know. Shoot. Oh, I got it. That was tricky. Yeah.
Does this make sense? Can you see that? I mean, are you sure?
Mhm.
I thought I'm stuck here.
Why?
It doesn't make sense.
All right, well,
Oh, no.
I don't know.
Is this the answer?
Let's see. Probably is. I didn't do it out yet, but it probably is.
Fine, I'll give you the wrong.
Yeah, I've been looking at
High school is.
I mean, I'm gonna keep it 100 with y'all though. Like, I do have like a lot to cover, so I might not like be able to teach y'all everything on the calculator. So that's what tutoring is for. You know, like y'all, huh? No, it's free. Yeah, it's online and in person, whichever works for you. Both, yeah.
I thought it.
What the- What the calculator? Just watch the videos again. Yeah. I'm gonna give you the link and everything. Just rewatch it, you know? Yeah, and it matches your homework. You know, it's gonna match the test and all of that, right? I hope y'all didn't write down none of the problems because that might be on your test. Let me just.
Right.
I'm not say that.
Well, that's.
I ain't do it yet. I don't know. I be making these up as I'm going, so I don't even. But you reduce it, right?
But if I need
Yeah.
to answer,
I'll take it.
great, like.
Right. Yeah.
Oh, I see.
Yeah. I got you.
I feel it.
All right, let's try this. Let's try this, right? Same procedure as before, right? I'm gonna keep the 1/4. And then I want the opposite of the 5/6, right? So what's the opposite of 5/6? Is negative 5/6, right? Just like that, right? And then now it's a fraction, so I have to get the same denominator. And then, so what is the LCD? 12, okay. So how do I change a 4 into a 12? 4 times 2, 3. Okay. I was about to write the 2 too. Like y'all about to y'all about to mess up the video. All right. How do I change a 6 into 12? Times 2, right? But what I do to the bottom, what I do to the top. All right. So now what do I have? I got 3, right? Over 12 plus negative 10 over 12, which is negative 7 over 12. Now we're talking. All right. Very good. All right.
We're almost happy with that, -20, you know.
Yeah.
-5/6.
Yeah.
Almost happy.
I feel you.
It's confusing.
But y'all getting it though. Y'all probably gonna finish y'all homework in like 2 minutes. Um, I said it last class. I don't even remember. Before the first exam. Before the first exam. No, it's on WebWork. I'm gonna give y'all the link. I didn't give it out yet. Huh? Really? Wow.
She's about to start again.
Oh, at the daycare?
Oh, my daughter goes to daycare.
Nice.
Last year, but
Yeah.
ninth grade,
Mhm.
I thought it was gonna be.
You could do that?
Yeah, that's what it
Yeah.
And then, where you would probably go take a class.
Yeah.
That's, yeah.
Damn.
Oh, yeah, because you're going to the college.
That's all right. You're gonna make more money than her, don't worry. That's okay. You're gonna make more money than her, don't worry.
I'm gonna show her this, and she's probably gonna be like, "Mom, come on, that's nothing. What's wrong with you?"
I can see you having like a future intellectual debate and be like, let me see a paycheck though. Like yo.
That's a good one. That's a good one.
Gotcha.
Yeah, she's a genius. I'm doing that.
All right, so we're doing operations with sign numbers, multiplication and division. So this is the easy stuff now. All right, so we just got over the hard stuff. All right. So multiplication of whole numbers emerge as an abbreviated form of addition. So for example, 6 times 3 means 3 added to itself 6 times. But to extend this simple understanding to all kinds of numbers, we require that the commutative and associative and distributive properties continue to hold, right? So it is not too hard, for example, to extend a definition of multiplication to all integers. So first, multiplying a positive number by a negative number, we can reason as to the following example. So we can think of 6 times -3 as -3 added to itself 6 times. So -3 plus -3 plus -3 plus -3 plus -3 plus -3, which equals -18, right? So, right. It's just like the next number just tell you how many times to add itself to itself, right? So if the negative number appears first, right, this is slightly more difficult. However, right, we can think of -2 times 4 as 4 added to itself -2 times. However, if we insist that multiplication of sign numbers should be commutative, then -2 times 4 must be the same as 4 times -2, right? So we just playing with the rules here. Yes.
It's gonna be a 10, coding the sign.
No. We don't get to that in this class. Yeah. If you switch to radiology, you get to see that though. Nah, trust me, you won't like it.
I don't wanna.
All right. Where'd I leave off? All right. So -2 plus -2 plus -2 plus -2 is equal to -8. So what should be clear from both of these examples is that the product of a negative number and a positive number is a negative number, right? What about multiplying a negative number by a negative number? First, we should convince ourselves, right, yourself, that the opposite of a positive number is a negative, right? And the opposite of a negative number is a positive. Second, remember that two numbers are opposites if their sum is 0. So let's consider the example -2 times -3. We will show that this number is the opposite of 2 times -3, right? So after all right, yeah, we're just breaking it down.
You see that highlighted part on top?
Yeah,
I feel like some people might get confused with what you said earlier, negatives and negatives are not positive. So that whole other.
they're not.
But with.
No, but right here you said.
Mhm.
We're talking -15.
What?
So.
Which one?
-2 times -3, and then it changes to 2 times -3, would that be -15? No. Why?
What's 2 times 3?
2 times 3 is 6.
Oh.
Oh, wow. Wow.
You gotta slow down.
You know what it is? Like you need the Starbucks. You know, once you got the Starbucks, it's straight. You know? All right. So after all, right, -2 times -3, right, plus 2 times -3 should be equal to 2 plus -2 times -3, which would be 0 times -3, which is 0, right? So this calculation shows that -2 times -3 is the opposite of 2 times -3. But we saw above that 2 times -3 is -6. So -2 times -3 is the opposite of -6, which is +6. So in conclusion, assuming that the distributive property is to hold, -2 times -3 is equal to +6. This example is meant to illustrate a famous but often little understood property of multiplication of sign numbers. The product of two negative numbers is a positive number, right? So finally, a word about division of sign numbers. We saw in context of fractions, right, that division is the same as multiplication by a reciprocal, right? So keeping in mind that two numbers are reciprocals if their product is positive, it should not be too hard to see that the reciprocal of a negative number is also negative and the reciprocal of a positive number is also positive, all right? So, oops. Let me continue in 1 second. So,
You know, some shortcuts.
oh, I love shortcuts. Oh yeah.
They'll stick in my head.
Y'all haven't seen shortcuts until y'all see me in tutoring. Like, oh my God, just do it like this. So I don't know yet. I didn't get my schedule yet. But when I know, I will let y'all know. Yeah. It doesn't open up till September 3rd. I don't even know what day of the week that is, but yeah, it's next week. But I don't remember what day of the week that is. That's a Wednesday. Okay, so then it opens up on Wednesday. I think schools close Monday,
Yeah.
something like that, Labor Day or something. Yeah. Yeah. Schools also close Saturday and Sunday in case y'all have class on Saturday, Sunday. Yeah. Yeah. Nah, for real, they got Saturday, Sunday classes. Yeah, for real. Yeah. Yeah, they got late night classes, weekend classes, all of that. You know, you might even get one when you get your clinical. It might be on Saturday or Sunday. Yeah, yeah. You say that till you in pediatric ward.
No, I'm gonna do adult med.
Okay,
I used to
gotcha.
work in the P.
They gotta like training for everything, that kind of thing.
No, yeah.
All right, so the purpose of sign number division will follow exactly the same rules as multiplication. So here's a brief discussion leads to the following rules of multiplication of sign numbers. So rules for multiplying and dividing numbers. The product or quotient of two numbers with the same sign is positive. The product or quotient of two numbers with different signs is negative, right? In both cases, the magnitude of the product or quotient is just the product or quotient of the magnitude of the two numbers. All right. Long story short, if they have the same sign and you multiplying them, the answer is positive. If they have different signs and you multiplying them, the answer is negative. That's it. All right. So notice how nice these rules are compared to the rules for adding and sign numbers. We never have to worry about which number has a larger magnitude. We always perform exactly the operation indicated in the problem. So now let's look at a couple examples. All right. I got you. Yeah, yeah, definitely. This is fun. I'm hold on, I'm gonna do a really, really easy question real quick. So I got negative 0.004 times, right? This the easy one right here. Yeah. Yeah. 'Cause I don't want to make this up out of my head because this might get real. All right. How I do this?
Let me turn it right. Right, boom, so you got it. You gotta break it down.
It's okay. Yo, we moved on real quick, like. So here's my way of doing this, right? I like to count how many digits I have in the numbers, right? The number that has the highest number of digits, I like to write that on top. So in this case, negative 0.004. And then the one with the less number of digits, I like to write that on the bottom. So 2.68. This is how I like to do my multiplication. That's a negative, right? I forgot to write the negative, right? This is how I like to do my multiplication, right? And then you just do it one by one, add up the answers, call it a day. That's it, straight down, right? So then let's do this. 8 times 4. Oh crap! I hope y'all know. What is that? What? That's fine. So I heard 32. So 2 and then a 3 up here. All right, what's 8 times 0? 0 plus 3? 3, right? And then 8 times 0, 0, 8 times 0, 0. Then y'all know y'all need y'all imaginary 0. Don't forget it. All right. Then we got 6 times 4. What's that?
24.
Good. So we got the 4, put our 2 up here now. Right? 6 times 0 is what? All right, plus 2, 2. All right, good. 6 times 0, 0. 6 times 0, 0. All right, now we got 2 imaginary numbers, right? We got 2 of them right there. 1, and we got 2. All right, what's 2 times 4? 8. All right, and then 2 times 0, 0. 2 times 0, 0. 2 times 0, 0. Then we want to add all these up together. All right, so then what's this? This is 2. 3 plus 4 is what again? 8, right? 7, thanks. And then 8 and 2 is 10, 0, 1, 1, 0, 0. All right, help me out. A negative times a negative is appreciate it. So my answer is gonna be positive. After that, here's my next trick, right? So I'm explaining the decimal now, right? So you start your decimal always at the end. Counts in both numbers how many numbers you have after the decimal. So in the first one, I have how many numbers after the decimal? 3, right? And in the second one, I have how many numbers after the decimal? 2. And then what's 3 plus 2 again? 5. So that's how many spaces I'm going to move my decimal here. 1, 2, 3, 4, and 5. Right? Going that way, by the way. Right? So my answer is 0.01072.
What is this today?
So now this is one way to do this. Another way we could have done this is we could have changed these into fractions. And then we could have just done what we were doing before. Right? But I do want y'all to know how to do decimal multiplication as well. What happened? Yeah.
I'm questioning our birthday.
Mhm.
Why?
Oh, by the way, before y'all leave, come up here and sign attendance and then y'all can do. Right?
You put number 1, Professor?
I did that.
So write my
Whatever.
name on there?
Yeah.
Okay. Today, yesterday, our birthday.
Y'all want to continue the whole number thing, go ahead, but just write your name clearly, first and last name. That's all. Yeah. I'm sorry? It's gonna be online on WebWork. I'll see you next week. Wait, tomorrow. I'll see you tomorrow. Yeah, tomorrow Thursday, no? Yeah. I thought today was Monday. So I'm in the same boat as y'all. Yeah. Actually, wait, no, I thought today was Tuesday earlier. Before I had my coffee, I was like, yo, it's Tuesday. I was like, what you mean? Like,
Wait, did we sign in yesterday? So what is it called?
sorry, no, it's all good.
Don't put me asking.
I got you.
What is it?
Which one? WebWork.
WebWork?
Yeah.
And.
So just Google BCC and WebWork, and then you can find it. It's in the first video. I'm gonna give that all to y'all.
Log in.
It's your first name and then your last name as one word. All lowercase. That's your username and your password. Yeah.
Now what's the password?
Your first name, the same thing. Username, password, same thing. Yeah.
Oh, first name,
All
last-
lowercase. No period, no space in between, just one word.
And then all the homework. What is it?
Yeah. Forgot when. Before the first exam. Like in 4 weeks. Yeah. Huh? Yeah. Y'all gonna get multiple links from me all like every week. Y'all gonna get links and
So
stuff.
I could come tomorrow, still, nothing. Okay, so.
Yeah, you good.
I did, the homework's not due until 4 weeks.
Yeah,
Okay.
yeah, we'll be good.
See you later.
Yeah.
Thank you.
I'm gonna ask family down question. Hold on.
I mean,
Okay, so we signed into WebWork,
yeah.
right? And it looks like that, like we